Hello everyone, let's discuss the numerical on plate load test. So this is the question. The following data was obtained from a plate load test conducted on a 60 cm by 60 cm square test plate at a depth of 2 meter below the ground level on a sandy soil which extends up to a large depth. Now, what is the meaning of this part of the sentence? Soil which extends up to a large depth. It means that the soil is homogeneous. One thing we should see here that the size of the test plate is very small. 60 centimeter by 60 centimeter. What will be the significant depth? 2 times the breadth of the plate. So it is 2 into 60, only 120 centimeter or 1.2 meter. But in the actual footing, the size is 4 meter by 4 meter. So the significant depth will be 2 into 4 equal to 8 meter from the base of the footing. So there is a huge difference between the significant depth of the plate and the significant depth of the footing. So if the soil is a layered soil, we will not be getting appropriate results through plate load test. Fine. In this case, there is no problem. The soil is homogeneous. Moving on, we are asked to determine the settlement for a foundation of size 4 meter by 4 meter carrying a load of 1200 kilonewton placed at a depth of 2 meter below the ground surface on the same soil. In question number A, we have to find the settlement without involvement of water table. In question number B, we have to find the settlement when water table rises up to the base of the footing. Okay, now moving on. Now, this is the load intensity and settlement data. Moving to solution, we should see that the plate load test is conducted at 2 meter, which is also the depth of the footing, which is the general procedure. Load coming into the footing divided by the area of the footing will give us the load intensity. Now we will draw one load intensity versus settlement curve. Now from this graph we will find out what is the settlement corresponding to the load intensity of 75 kilonewton per meter square. Settlement of the plate was seen as 3.75 mm corresponding to the load intensity of 75 kilonewton per meter square. From the same curve, we can find out the ultimate load. If there is a clear ultimate load, we can take that value. If there is no clear ultimate load, we have to draw tangent and take the corresponding value. This is the formula which relates the settlement of the plate to the settlement of the footing given in IS 1888-1982, clause number 5.3, page number 10. This is the page from IS code. The formula, the values are to be given in meter. Using this formula, we find the settlement of the footing. Done. Question 5a over. In question 5b, we have to find the settlement when water table rises up to the base of the footing. Now remember that water table correction factors are always less than 1. In case of bearing, what we did, we multiplied with the water table correction factor because the bearing capacity always reduces due to presence of water. In case of settlement, what will happen? The settlement value will increase due to presence of water table. Therefore, we have to divide with the water table correction factor. So, applying the water table correction factor, which is equal to 0.5, remember that water table correction factor was 0.5 when water table is at the base of the footing or above. It changes linearly from the base of the footing up to a depth equal to width of the footing where it becomes 1. So applying the water table correction factor, we find the settlement when there will be water table at the base of the footing. Now question number 5c. We are asked to find the allowable bearing pressure for a footing of size 4 meter by 4 meter at a depth of 2 meter. Permissible settlement, factor of safety and unit weights are given. Now to find out the ultimate load for the footing, we have to find the ultimate load of the plate, which we will get from the load settlement curve of the plate load test. Now this is the load settlement curve. From this curve, we do not get a clear-cut ultimate load. So what we can do, we can draw two tangents. one tangent to the initial portion of the curve and one tangent to the final portion of the curve, where the two tangents intersects corresponding to that whatever is the load intensity is the ultimate load for the plate. Now, ultimate load of the footing divided by width of the footing is equal to ultimate load of the plate divided by width of the plate. Using this relationship, we find what is the ultimate load of the footing. After that, we look into the fact that plate load test is conducted on a test pit. The soil is removed when conducting the test, and therefore no charged soil is involved in the test. This is the formula for finding out net ultimate load. C value will be 0 because it is a sandy soil. Finally, we are writing the expression for ultimate load with correction factors for rectangular shape. Depth corrections are not required because we are conducting the plate load test at the same depth where the footing will be constructed. As the surcharge soil is not affecting the plate load test, so the ultimate load from the plate load test will be equal to the term half B gamma N gamma and S gamma. So equating these two, we find out the value of N gamma. Now corresponding to this N gamma, we will find out the value of phi because we do not know the value of phi in this case. Now this table we already know. This is from IS 6403, the table where we find the values of NC, NQ and N gamma corresponding to phi values. Generally we know the phi value and then we find out the NC, NQ and gamma values, but in this case we are going in the opposite direction. We first found the N gamma, then we will be finding what is the value of phi. Corresponding to that value of phi, we want to find out the NQ value. Here we are doing linear interpolation. We found the N gamma value as 52.19 and we see from the table that phi value has to be in between 35 degree and 40 degree. We do linear interpolation and we found the phi value as 35.34 degree. Now this value is less than 36 degree. So we have to find out NQ corresponding to phi, which is 35.34 degree. And then NQ dash corresponding to phi M, which is 25.4. Now we have to interpolate between NQ and NQ dash as shown. This we have already done in previous numerical examples, so we will not be discussing in detail. If you have any problem in this interpolation, kindly let me know. Then we find the ultimate load, the net ultimate load, and then SBC using a factor of safety of 2.5. Now we have to find the SBP, safe bearing pressure. Allowable settlement of the footing is given as 50 mm. What will be the settlement of the plate corresponding to a settlement of 50 mm to the footing? That we can find from the formula given in IS code 1888-1982, clause number 5.3, page number 10. Using this formula, we find what is the settlement to the plate corresponding to a settlement of 50 mm to the footing. Using this settlement of the plate, we go to the load settlement curve for the plate load test and we find the loading intensity. Now this loading intensity will be the safe bearing pressure for the footing. Finally, the smaller value of safe bearing capacity and safe bearing pressure will be our allowable bearing capacity or allowable bearing pressure. Thank you.